Alright, today we're going to be working on 11.1, which is the areas of triangles and parallelograms. And we're going to start with a little bit of vocabulary. So the bases of a parallelogram. Either pair of parallel sides of a parallelogram are bases. We have one set of parallel bases here, and we have another set of parallel bases here. So the height of the parallelogram is the shortest distance between bases of a parallelogram. So in this case, we're looking at our two bases with one arrow, and the height is represented by the yellow line. And it's important to recognize that attached to the yellow line is the perpendicular symbol. And the reason that it's the shortest distance is because it is perpendicular to the base. So that's one thing we always need to keep an eye on. And let's look at some postulates. So postulate 24, the area of a square. The area of a square is the square of the lengths of its sides. So what's that saying is, if we have a square with side marked S, the area is going to be equal to S squared, or side squared. If that square had side length of 5, the area would be equal to 5 squared. And looking at postulate number 25, we have the area of congruence postulate. So if two polygons are congruent, then they have the same area. And if we look down at these two polygons below, if both of these had the same dimensions, since each of these sides are the same, then they would also have the same area. And postulate number 26, this is another important one. It's the area addition postulate. So the area of a region is the sum of the areas of its non-overlapping parts. So let's take my first grade house, for example. When I first learned to draw, I drew my house, and you see it's made up of, we'll say, a rectangle and a triangle. So if we were trying to find the area of this entire region, we'd have to find the area of the rectangle, which is here, and we'd also have to find the area of the triangle, which is here. And we would add those up, and that'd give us the entire area of the region. And looking at the different formulas for each of the areas of our different shapes. So the area of a rectangle is equal to little b times h, which is base times height. And the area of a parallelogram is also little b times h, which is base times height. And the area of a triangle is 1/2 times little b times h, which is base times height. Now, when we get to three-dimensional figures, there will be a big B, so a capital B, and that will mean something different. So it's important to recognize that the area of a rectangle, parallelogram, and triangle all deal with little b, which is the base. So let's do our first example. It says, find the area of parallelogram PQRS. The area formula for a parallelogram is area is equal to little b times h, which is just the base times the height. There's a couple different ways we can do this. The first way, I'm going to say for the area, my base is going to be 6. So if I use 6 for my base, now I need to find my height. In order to find the height of my parallelogram, I need to find the lines that create a right angle. So if 6 is our base, we have to use 8 as our height, because you can see from our base down to our other base, these two lines are perpendicular, and the height of that is 8. So we're going to do 6 times 8, which is going to give us 48. And it's important on these types of questions to look at the units. There are no units in this problem, so we're just going to say u for units squared. And the second way we can find the area of this parallelogram would be to use 12 as our base, because we can use either pair of parallel sides of our parallelogram. 12 is a base, so in this case I would have to use 4 as my height, because 4 is created by this line here, which creates a right angle with my bases. So in both of these, as you can see, when we chose the height, it was all based off of which line created the right angle between our bases. If we continue working this out, we should get 48 units squared. And for our second example, we are going to find the perimeter and area of the polygon. So if I'm going to find the perimeter, I need to add up all of the sides. So since we have parallel bases here, we know that they're also going to be the same length. So our double arrow base will be 30, single arrow will be 20. In order to find the perimeter, we just add up all the sides. So I'm going to start here at 30, and I'm going to go counterclockwise around the figure. 30 plus 20 plus 30 plus 20. And this will give our perimeter a total of 100. Now, we need to find the area of our shape. So now we know it's a parallelogram, so the area formula for a parallelogram is base times height, which is little b times little h. For our base, I'm going to choose 30. And if I choose 30 as my base, I need to find the height where we find the line which is the shortest distance between our two bases and should create a right angle. In this case, the only other line up there will be 17, so we're going to use 17 as our height because it creates the right angle between our two bases. And when we multiply these two numbers together, we should get 510 units squared. In another example here, we're going to find the perimeter and area of the polygon once again. It's important to recognize that this is not a parallelogram, it is a triangle. So our area formula will be different, but the perimeter will stay the same. All we need to do is add up each of the sides. So we're going to start at 21 at the base here and go counterclockwise. 21 plus 10 plus 17 will give us a total of 48. And now to find the area of the triangle, we are going to use our area formula, which is 1/2 little b times little h, which is base times height. We're going to bring down our 1/2, and our base here is 21, and we need to find the height of our triangle, which is going to be the shortest distance, and it should create a right angle, so that is our 8. So if you were to multiply this all out, final answer would be 84 units squared. Now for our other example, we have the base of a triangle is twice its height. The area of the triangle is 36 square inches, and we need to find the base and the height. So we're solving for the unknown measures here. So let's break down the problem a little bit. It says that the base of a triangle is twice its height. So we can see here the base, which is 2h, is twice the height. So they just took h, multiplied it by 2. And the area of the triangle is 36 square inches. So we need to find the base and the height. So I'm going to write down our formula for a triangle, which is area is equal to 1/2 little b times little h. So let's fill in what we know. We know that the area of the triangle is 36 square inches. We know 1/2 will stay the same because it's part of our formula. And we know that our base is 2h and our height is just h. Let's go through and solve this. What I'm going to do first is bring down my 36 and my 1/2. I want to multiply inside of the parentheses, so that's going to give me 2h squared. We can distribute our 1/2, which is going to give us h squared. These will cancel out. Now we just need to find the square root of each side. Our height is going to be equal to 6. So if we come over here, we already know the height. We know our height is 6, and we know our base is 2 times our height, which is 6, which will give us 12. We need to look back at our problem, and it says that our units will be in inches. And finally, now we're going to solve a multi-step problem. So it says that we need to buy paint so that we can paint the side of a barn. A gallon of paint covers 350 square feet. How many gallons should you buy? So here we need to use our area addition postulate because we have two different shapes. We have a rectangle and a triangle. If you remember back to previous when we were going over the area addition postulate, I used the example of my first grade house, and so this is very similar to that. The first thing we're going to do, let's find the area of the rectangle. The area of a rectangle is the length times the width. We're going to do 26 times 18, and this will give us 468 feet squared. And so now we need to find the area of our triangle. However, as you can see, we are missing 2 of our lengths. There are a couple different ways we can find this. We could use trig, or we could use a Pythagorean theorem. if we use the Pythagorean theorem, we would find out that this length here is going to be 13 square root of 2. And because these are congruent, this will also be 13 square root of 2. We can find the area of our triangle, which is 1/2 the base, little b, times the height, little h. So if we were to do this, I'm going to carry down my 1/2. And I need you to imagine we turn the triangle so that this side here is our base. And so if that was our base, we're going to use that. We're going to say we have 13 square root of 2, and we're going to multiply that by the side that creates a right angle with our base. And so in this case, it's also, our height is also going to be 13 square root of 2, because it is the side that creates a right angle with our base. After we multiply all that out, this will give us 169 feet squared. But we're not done. We need to find out how many gallons of paint we should buy. So we have the area of our rectangle and we have the area of our triangle. So now we need to find the entire area of the region. So now we will add both the area of our triangle to the area of our rectangle. So if we were to add 468 plus 169, that'll give us 637 feet squared. And we need to find out how many gallons of paint. So we are given that it covers 350 square feet. So we need to divide our 637 by 350. It's clear to see that 1 gallon of paint is not going to cover the entire side of our barn. If we do 350 times 2, that's going to give us 700 total feet that we can cover. And so that will give us enough paint to cover the entire side of the barn. So our final answer is going to be 2 gallons of paint.